Hi everyone. In this video we will see that how we can extract data from an XML file using Power Query, and we will also see that how we can expand multiple nested tables using recursion in Power Query. So this is going to be an interesting video as we will be focusing on recursion in Power Query. So do make sure that you watch the video till the end. So let's first of all have a look at the XML file that we have. So this is the XML file. Let's try to open and read this. So this is the information that we have got here. So we have got continent, let's say it is Asia. Then within the continent, we have the country, let's say it is India. Then within the country, we have states. So we have got a state as Karnataka. Then we have also got a state as Maharashtra. Then within each state, we have cities. Within each cities, we have neighborhood. Then we have street. Then we have buildings. So this is the kind of nested structure that we have here. And we will see that how we can extract all this data in form of a table using Power Query. So that is going to be our agenda for this video. So let's see. Let me close this file for now and let's go to Excel. So let's go to data tab, get data from file from XML. And this is the XML file that we are trying to import. So let's click on import. And again, the same steps can be replicated in Power BI as well because Power Query is same in Power BI and in Excel. So this is the table that we are trying to transform. So let's click on transform data. And we have our table loaded in Power Query editor. So let's remove this change type step. We don't need that. And this is the table that we have. So we have got this continent column. So we have Asia here as continent. And for this continent, we have got this country column. And what does this country column contain? It contains a table. It contains a table with the information about states in each of the countries, right? So this is the structure that we have. And again, if you see what we have again in this state column, we have got multiple tables here. So this is the kind of nested table structure that we are trying to deal with. And we will see that how we can deal with this nested table structure to get our final output. So what we will do as our first step, we will rename this manually here. So we will rename this as continent, right? We will rename this as continent and we will again rename this step as well. So let me remove the extra part from here. So this step, rename step, is going to be manual. This until here our steps would be static, and after that we will try to make our steps dynamic so that it keeps on expanding tables until a final condition is met, right? Until the final output is achieved. So what we have got here, we have got continent column, and what we will do now, we will expand this country column by clicking on this icon for expanding, and we don't want to use original name as prefix. So let's click on OK. Now we have expanded country column. Then we will expand this state column. So again, let's click here. Let's click on OK. We will have to again expand. So let's click here. Let's click on OK. Again, click here. OK. Click here. OK. Click here and OK. So now finally we have reached our desired output. So this is the result that we are trying to generate, and we have got this. But again, this is not dynamic because it could have contained more table as well, more nested tables, and we will have to expand that manually. But we don't want that. We want to expand our tables dynamically so that in case in future more nested tables are added, any number of nested tables we have here, if they are reduced as well, so it is dynamically expanded. We don't want manual intervention there. Right. And again, there is lot of manual thing here. So these are all referring to previous steps, not dynamically, but these are hard coded things here. So if anything changes here, we will have to manually intervene here and change these things. Let's change these names here. So again, we will try to make that thing dynamic as well. First of all, we will try to make this expansion thing dynamic, and we will also try to make this thing dynamic so that the renaming is controlled here. Renaming is not proper here as we can see here, so we will try to fix that as well. So let's see how we can do so. So if we observe the thing here, how we can say that, okay, we have reached the final output. How we can say that? Because if we see here, if we see all the previous steps had tables in the first column. So it has tables in first column. Again, this table also has tables in the first column. This also has tables in the first column, but this final output table doesn't have any table in the first column. So that's when we can say that, okay, we have reached the final result, final output that we want, and this is where we have to stop. So that is how we will program our condition, that when we have to stop when the first column of the table doesn't contain any table, right? So this is going to be our condition. And now we will see that how to program that function part, that expansion part. So if we see here, if we examine here, what we have got this table.expand column function. Again, we have the same function here. We have the same function here, here, and here as well. So this is the function that we are trying to work with. So we know that we will be dealing with this particular function, table.expand column function, right? So what we are doing basically, this is going to be our input table, the first table that we will pass into our function, and then we will make our table.expand column function dynamic so that it keeps on expanding until we are reached here, until our final condition is met. This is going to be the basic framework that we are going to follow. Now, within this table.expand table column function, what we have basically three required inputs. This fourth input is optional, so we can avoid this. But we have three critical inputs that we have got here. So it has got table, right? It has got three inputs: table, column, and column names. So it has got table. Now this refers to the previous table. So this was the source table that we had again, right? So this is the previous table. Now for this step, this is the previous table, expanded country table, right? For this, expanded state is the previous table, right? It is the table input for this function at this iteration. So what we are doing basically, we are referring to the previous table, the table generated at the previous step in this table.expand column function. This is the part one. Now part two is which column from that previous table are we trying to expand. So if we see here, we are trying to expand country column from the previous table, the source table here for the first iteration. So we are trying to expand the country column. And what is the country column? It is the first column name for this table. Similarly, when we are expanding this table at this step, what is the name here? State. And how we are getting this state column here? This is the first column name for this particular table, the previous table, right? Again, city here, we are expanding city column. And how we are getting this? If we move to previous step here, this is city here, right? This particular city column we are expanding. So we have got an idea of how this particular part is working and how to get this. So we have got this fixed here. And now let's move to the final step, that is this part. Now what is this part basically? So at this step, this is city comma attribute name. This step refers to that what are the columns that we are expanding and what are the new columns that are getting added here. So what are the columns that are getting added here? They are city and attribute name, right? So if we see here in the previous table, in this state column, so we know that we are trying to expand state column. Then within this state column, we have got multiple tables here. Then for each of the tables, what we have table names here. So city and attribute name. City and attribute name are the columns that will be added to the new expanded table here. So that this is the part that is corresponding to the column names, list of column names that we have in this list of column names that we have in this in each of these tables here, right? So this part is bit tricky, but we will deal with that. So what we have three components here: table, the first column name, and the list of column names within this first column, right? So this is what we are dealing with. So what we will do basically, this is the manual step that we have generated here. What we will do, we will create a duplicate of this. Now what we will do, we will try to make each of these components dynamic so that these are not hard coded here, right? So let's see. And what I will do, I will remove all the steps until end from this step, right? So now let's try to replicate this complete thing, this expanded city step, so that none of the things here is hard coded, right? None of the things here is hard coded, and we will try to generate this particular table dynamically that refers to the previous table, that is expanded state step here, right? So what we will do, first of all, we will create parts. So this is going to be part 1. Then we will have part 2, and then we will have part 3. So part 1 is pretty straightforward. Part 1 was this component, the previous table, right? The previous table. For expanded city, for expanded country table, previous table was rename table, right? For expanded state, it is going to be expanded country table. For expanded cities, it is going to be expanded state table. So here we are just referring to expanded state table, right? Expanded state column, expanded state step. So we have this table here. This is part 1. Then the second component is the first column name from this previous table. So we want this city here, right? We want to generate this city as part 2. So what we are trying to do basically, from part 1, which was the previous table, what we are trying to get, we are trying to get column names. So table dot column names function is the one that we can use here. So we will get the list of all the column names here as a result of this particular function. So we have got this list, and what is this list? This list contains the column names that are generated at this expanded state step, right? And from this we want the first column. So we will use this kind of indexing, and we only want the first column name, which is city here. So we have made this part dynamic as well, city. So part 2 is done. Now let's move to the third component, which is going to be a bit tricky, but let's see that as well. So this is going to be the list of column names that will be generated as a result of the expansion. So if we see here, expanded state column, we have this column here, and in this we have two tables. First table contains neighborhood attribute name. Second table again contains neighborhood and attribute name. And again, this is the same thing that we have here, neighborhood and attribute name as a list. That what are the new columns that will be added as a result of expansion, right? And again, the extra challenge added here is that, let's say this is the column that we are trying to expand, and within this we have multiple tables. Now each of these tables could have uneven number of columns or uneven column names as well. So this could have, let's say, only two columns, but this table could have, let's say, three to four columns. So we are trying to expand all the columns from both these tables, from all the tables in this city column, right? So that is another challenge that we'll be dealing with. So our first step would be, from part 1, that is the previous table, we will get this first column here, and we already have that as our text here, city. So we are trying to get the city column from this table. So what we will do, we will use table.column function here. Table.column function, what it does, it takes table as an input and column as text. So which column are we trying to extract here? So it is city column, and we already have city in part 2. So we have got this first column from this expanded state step, right? So we have got this list of tables, and we are trying to extract a unique list of columns that we have in each of these tables here. So as our first step, what we will do, we will use list transform to get a list of columns for each of these tables, right? So we will use here table column names. So what we have got a list, and within this list we have a list which contains the list of columns for each of the tables. So if we see here, we had this first column and it had two columns, neighborhood and attribute name. Second column, second table also had neighborhood and attribute name. If we see here again, neighborhood, attribute name, neighborhood, attribute name. So this is what we have generated. So at this point, we got the first column from the expanded state step. Then we got that as a list, and we transformed that list to get the column names for each of the tables in that column. So we converted that into a list of column names. Now what we will do, we will combine all these lists together. So we will use list dot combine function, right? To combine all these lists together. So we have got a consolidated list of all the column names from all the tables from that column, right? Now what we will do, we will use list.distinct function to get a unique list of table column names that we are trying to add to the new expanded table. So we have got this list here, neighborhood attribute name. And if we check here, we have got neighborhood and attribute name as a list here, right? So we have got this here. So we have got part 1, part 2 and part 3. Finally, we will put them all into, finally, we will put them all together here. So what we will do, we will use table expand table column part 1, comma part 2, comma part 3, right? So we are getting this error, attribute name field already exists in the record. Why we are getting this error? Because if we see the expanded state column, we already have attribute name column here. And when we are trying to add new column, we are trying to add attribute name column as well. So again, it cannot be added twice here. So this is where part 4, that is this particular component, comes into picture, where we are renaming the column names, right? So what we will do basically, we will rename this. So neighborhood will remain same, but the last item that we have here, so this last item will be renamed to, let's say this is going to be our city, right? So we will rename this to city here. So if we change this to city here, you can see that this is renamed to city, and this is actually cities. These are actually cities only, right? So this is what we are trying to do. We will keep the first part of the list as it is, and we will replace the second part to city, and we already have city generated in our component 2, part 2, right? So we will add another thing, another part here, that is part 4. And what it is going to be, again, it is going to be part 3, right? Part 3. And we will remove the last item from this list, remove last 10, and we are removing the last item from this list, and we will then append this list with part 2, because part 2 has city there. So we have got city there, right? So again, this is not a list, so that's why this is creating an issue. So part 2. So we have neighborhood and city as our list. Again, this is same as part 4 here, neighborhood and city. Then finally, let's try to get all these things together, all these components together in table.expand table column function, part 1, comma part 2, comma part 3, comma part 4, right? And finally, we have this table here. So we have expanded this particular table dynamically using only this as our input. Now, what we will do, what fun part we will do in this part 1, now we will refer to city table, right? This city table, we are referring to the city table. This is going to be our uh, 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 starting point. So now if we see here, the neighborhood column is dynamically added here to the city table. And if we see here, it is exactly same as this particular table here. So these are going to be our steps, and this is how recursion will work. This will be the input table. This will be the input table. We will apply, first of all, we will generate all these parts for this input table, right? And then we will generate this particular table. Let's say we rename this as final table, final table, right? Final TBL. We will generate this final TBL from this rename table. Once this is generated, if we, let's say, change this to rename, then we can see what is generated here. We have got this particular table which contains state, country, and continent. This is similar to this one, state, country, and continent. And again, the column name is also fixed here, right? As a result of following these steps. So we will use this as our input. At first iteration, we will use rename table as our input. We will generate this particular table, right? We have generated this here. Then we will use this particular table as our input at P1, and we will generate expanded state column, expanded state table. Then we will use this particular input again to generate this table. Again, this as our input to generate this table. And finally, where we have to stop, once we don't have any of the tables in the first column of the input, right? So let's see how we can satisfy our condition as well. So let's see if our condition is satisfied at this particular instance. So let's see this here. Is our condition satisfied? Let's see. So we will test the P1 here. So what we will do, from P1, right? P1 is going to be our input table. What we will try to extract, we will try to extract the first value, table first value, right? So from this, the first value is again a table. So we have got this table here. And is this a table or not? Yes, this is a table. So, right. So this is true. Now, how this is generated, table dot first value. So we are checking the first column, first row, first value here, and we will see that is this a table or not. So yes, this is a table. So we will keep on doing all these steps again and again until this is turned into false. So once this turns into false, that means we don't have a table here at this place. So that's when we have to stop, right? So if we change this to, let's say, expanded state column, expanded state table. So again, we have a table here. This is again true. So we cannot stop here. We have to keep on moving until this is turned into false. So let's try to glue all these steps together and let's see how recursion comes into picture to do this process until this condition is satisfied, right? So for that, what we will do, we will again duplicate this step and let's rename this to recursion, right? And we will remove all these steps until end from here. So this is going to be our input table here, right? This is going to be the input table because we will start expanding from this table itself, right? So what we will do, we will create an step and this is going to be our function recursive fn, right? This is going to be a recursive function. And what it will take a table as input. So tbl as table, which is going to be the previous table, right? So tbl as table. This is basically the part one, the previous table, right? TBL is our part one. So TBL, and let's say we get TBL in return for now. So we have this function in here in place, and we have named this as recursive fn. So we are done with part one. Let's see part two. So what does part two do? It refers to part one and gets the first column name from that. So let's copy this from here. Let's come here and let's create a record here, right? So let's name this as part 2. Part 2 equals to this, and we can use tbl here in place of part 1, and let's change this to part 2, right? Because finally we are getting part 2 here. And let's also do one thing. Let's apply this recursive fn function to rename table, right? So we have got country here because rename table's first column name was country. Then let's try to replicate part 3. So let's copy part 3 here. Let's come here and in our fn, let's update part 3 as well. Let's copy paste this, and this is going to be our part 3. Part 3 equals to, and we have part 2, and in place of part 1 we will use tbl again because it refers to the previous table, and we want to see part 3 back, right? So if we see, we have got this here. Then let's come to part 4. Part 4, let's copy this. Let's again come to our fn, and again we want to see part 4 here. Part 4 equals to this, and it refers to part 1, and in result we want to see, let's say, part 4. So we have got part 4 here, state and country here, right? Then final tbl. So let's copy this, let's come here, let's go here, and as our final tbl, we wish to see this, and in place of part 1 we can use directly tbl here, and in result we wish to see final tbl, right? And this is the table that is generated as a result of applying this function to renamed uh, table, right? So we have expanded the first column, that is country column, so that we got country separated here, continent here, and the state column here. Then again we have to expand here, and until when we have to keep on expanding until this is this is satisfied, and right, until this is satisfied. So we will again go here and we will add this condition here, that if this is true, so we will change this part1 to tbl. If this is true, then what we have to do basically, we have to then what we have to do, we have to perform this function. We have to keep performing this function. Else what we want to see, else we want to get that final table back, right? So this will be the final table generated here, and we wish to get that here. So we have to keep performing this function until we are getting this as true. And again, that is going to be a recursive exercise. At the first step, if we see here, this is the result of the first iteration, right? This is the result of the first iteration. Now at this iteration, when we transform this rename table, our condition is satisfied. Our condition is true because the first value of this table is true, right? So we again have to transform this table back. So what we will have to do at second iteration, we will again have to use recursive fn, right? Recursive fn on the previous table, the table that we generated at first iteration. So we will rename this as I1, right? I underscore 1, and this as I underscore 2. This is iteration 2. Now again at iteration 2, our condition is satisfied as this value, this first value is still a table. So we will again apply a recursive fn function on the previous table, that is I2. So we will again apply a recursive fn function on I2, right, on the previous table. So now we got this as a result. So again, at each iteration, we are expanding by one more column. Again, here we have expanded to one more column, that is city. Previously, we had city, but we had, let's say, tables here. Now we have city and we have neighborhood as well. So now we again, our condition is satisfied. So we will again have to use recursive fn function, and this is I3. Now we will again have to use it. So this will be I4, and we will use it on I3 now, recursive fn. We will have to transform it again. So I3 on I3, and again we have got this as a result. Again, this is not satisfied, so we will again call recursive fn function. So iteration 5, right? So we will again call recursive fn function. So we have got this, and again we will have to call this, right? So if we call it again, I6 recursive fn. Now we could see that we have got finally our result, right? And if we, let's say, try to apply recursive fn function again on this, so if we try to apply this, so you can see that it is giving us the same result. I6 and custom one at iteration 7, if we name this to iteration 7, I7, I7, then result of I7 and I6 is same. And if we do I8 as well, then the result would be same, because finally we have got a result. Finally, our condition has turned to false because this is not of type table. So our condition is broken, our loop is broken, and we have finally moved out of it, and we have got our desired result. Right. So this is going to be our result, and this is going to be our process. What we are going to do basically, at each iteration, let's say at the first iteration, we called recursive fn function, right? Then what happened? The condition was satisfied. So we again called recursive fn function. So what we could do basically, if we copy this part and if we paste it here, right? If we paste it here, then the result is same. If we again copy this part and paste it here at this iteration, then the result would be same. We again copy this, paste it in iteration 4, then again result would be same. Copy this, paste it here. In place of this, result is same. Copy this and paste it here. Result would be same. copy this, come here, paste it here, and result would be same, right? Result is same. So let's say if I remove this, if I remove this, right? If I remove this, no impact here, right? No impact here. Why? Because we have used this as our source table, and we have repeatedly applied recursive fn function here. We are not referring to any of these steps here, right? So that's how recursion works. How does recursion works? The same function recursive fn calling itself again and again, again and again until a particular condition is satisfied. So we have this function in place, recursive fn, and it is defined here, right? This recursive fn function is defined here, and we are testing this condition that if the table that we are passing in, right? So the table that we are passing in is renamed table. So if the table at first iteration, if the table that we are passing in is, if this condition is satisfied, then we are calling this function again, right? We are calling this function again. Else we are returning this table back. So what is happening at this iteration, the final iteration? We gave this complete part, right, inside recursive fn, and since our condition has turned to false, so it gave us this table back, right? So this is what is happening, and at each iteration we are referring to the previous table. So at iteration 1 we are referring to rename table, and at all the successive iterations we are referring to the previous result that has been generated as a result of recursion. So that's what we are trying to do, and let me make a duplicate of this. So this is what I'm keeping just for reference, right? A reference, and this is the main function that we are trying to do. Recursive recursion main, right? So here we will try to do this, and we will delete all these things. And so right now this recursive fn is just a simple function. There is no recursion happening here. In order to force recursion, we will have to use @ sign here, right? We will have to use @ sign here. So what we will have to do, basically, what we are doing, we are performing this function, right? We are performing this function, and this is generating a output which is a final TBL, right? It is generating an output which is a final TBL. So we will again call recursive fn function here, recursive fn, which again takes this as input, the transform table as input, and it tests this condition. It tests this condition. So if it is satisfied, then it again calls this function. If it is turned to false, then it returns the TBL. So this is what is happening here, and if we try to run it, it will give us this error, the name recursive fn wasn't recognized. So in order to force recursion, what we will have to do, we will have to use @sign here. So we will use @sign here in order to force recursion here, and this will create a function for us, recursive function for us. And now if we try to perform recursive function on rename table, we will get our final output like this, right? So this is the final output, and it gave us the final output in one go, right? We don't have to apply all these steps. We don't have to apply all these steps. It just did it like this. And this is the power of M language and recursion in Power Query. So this is how recursion works. And I hope from this example, it was clear that how recursion works. It is nothing but a function calling itself again, right? Until a particular condition is satisfied. So this is how recursion works. And if we see here, these, we don't have to perform all these steps, and all these column names and all those things, all the challenges that we discussed earlier, all those are very well tackled here by recursion. And also one thing that, let's say in future, if more nested tables are there, so within buildings, let's say we have different lanes or anything like that, if we even have more layers of nested tables, then recursion could very well handle that dynamically. So our output is dynamic, and column names are dynamic, and everything that we have done here is dynamic. Nothing is hard coded here for now, except one thing, that we have renamed this column to continent, right? So that's it for this video, and I hope you like the video and like the complete walkthrough of the process that we did for expanding nested tables. And do let me know in the comment section any other scenarios where we could use recursion like this, or any other topic you would like me to cover in the next video. So that's it for this video, and stay tuned for more such videos. Thank you.